Okay, we're going to look at the equation of a circle. So the equation of a circle, they call this the parent function of equation of a circle, looks like this. Be x squared plus y squared is equal to r squared. This is the equation of a circle, and we'll draw our coordinate grid here. Oh, I don't think I get shapes on this. Oof, that's not good, because I am not good at freehanding circles. I am going to try my best here. I find this actually messes me up when I do this, but I mean, not terrible. This is our circle here. What's important about this is I want us to realize that this equation of a circle is only for circles that the center is at the origin, at 0 and 0. Okay? Technically, the general equation of a circle looks a little more complex. It would be like ax minus h squared plus b x minus maybe k, y minus k squared equals r squared. So there's a lot more going on. We're using a really specific one. Okay? In other words, the middle of the circle is always at 0, 0. And the only thing that changes is the radius of the circle. The radius happens to be r squared. Okay? So, r squared. If we take a look at this, can you guess from my very excellent drawing here what the radius of this circle might be?
The radius of it?
Yeah.
Not like.
It's hard to tell, but if we take a look closely, I'm tried to make the radius equal to 2 units. Obviously it's not perfect all the way around because it kind of comes in, but I used some key points here. I use key points on this grid to help me draw the circle. This one here being 2, 0. This one here being 0, negative 2. This is negative 2 and 0. And this one here is 0 and positive 2. Okay. What's great about these coordinates is they instantly tell us the radius of the circle. They are the farthest point, so they have an R2. So if I was to actually draw the equation of this specific circle, only thing I have to change is the R value. So I would say x squared plus y squared is equal to r, which in this case happened to be 2, squared. So the actual equation is x squared plus y squared equals 4. That would be the simplified version for this specific circle that I drew there. Okay, so with that being said, if I want a circle, or actually let's do the opposite. Let's say I have an equation of a circle like this. Is equal to 49. Looking at that, we have to discover how far the radius is. Let's say that, hey, I can graph this. This isn't that hard to graph because I know I'm going to draw another Cartesian plane down here. I know that my origin is going to be here at 0, 0, but I do got to figure out radius. I got to figure out radius in order to make a sketch of this. So I have this part here. How does that relate? Well, what we're going to do is we're going to draw the parent function on top of it. Parent function is one that just has variables representing everything. So it turns out r squared is equal to 49. So I can turn that into my own little equation. I can say r squared equals 49, and the goal is to just isolate for r. So we take the square root of both sides. This would, square root in the power of 2 would cancel out. We'd get r is equal to plus or minus, technically there's 2 answers there, of 49. Square root of 49 happens to be 7, so my answer is either plus 7 or negative 7. We usually don't say a circle has a negative square root, so we can drop that one off. Our radius happens to be 7 in this question. So if I count out 1, 2, 5, 6, 7, that's going to be way too big. 2, 7. I'm going to do my best here. It's not going to turn out. Wait, what? 1, 2, 3, 4, 5, 6, 7. Oh, I only drew 6 there. Yeah, I looked off. That should be 7. There's no way the one on the left is correct either. Let's check that again. 1, 2, 3, 4, 5, 6. I think I drew 5 there. Okay, here we go. And my amazing circle. Oh, I messed that part There's my circle. But we have it. That's the circle we have. A few other things I want to talk about with circles. They might tell you it has a certain intercept. We can take a look. It gives us our two x-intercepts really simply. Our intercepts are either 7 and 0, or x-intercepts, and -7 and 0. Or y-intercepts happen to be 0 and 7, or 0 and -7. So our intercepts, as long as the center's at 0, are actually the radius and 0, whatever that radius is. And then there's a tricky thing. Points along the circle. So this equation that I made up a little earlier, x squared plus y squared equals 49, they might actually ask us for coordinates along the circle. They might say, is this coordinate on a circle? You can check this by seeing if the left-hand side of a circle of the equation equals the right-hand side. So maybe they'll ask us something like, let me see if I can take a guess here. Look, I drew through this point. I get the feeling that point's not really on there because my sketch isn't great, but that coordinate happens to be 1, 2, 3, 4, 5, 6, 1, 2. This happens to be 6, 2. So here's a question. Is 6, 2 actually on this circle? Well, this represents an x and this represents a y. So what we can do is we can actually replace this x and this y with those values, and we got to see, does the left side equal the right side? So we'd get 6 squared plus 2 squared is equal to 49. Well, 6 squared is 36 plus 2 is 4 equal to 49. And when we do this, we end up with 40 is equal to 49. Is that true?
No.
No, that's not true. So because it's not true, that means 6, 2 is not on that circle. Okay, in fact, there's probably some decimal value and it's probably closer around here. It's probably like 6 point something and 2 for all I know. I could reverse engineer it, but I don't think you guys actually end up getting into that piece because that has to do with, well, actually, it's not that too difficult. Here, let's do this. Let's say, shoot, I didn't get it. But I want to know when the x value is 6, what y value would be on the circle. We can still figure that out. We'll take the original equation, x squared plus y squared equals 49. Okay, and we said, hey, we want to know what are the y values when x is 6, the y values are equal to what? What are the possible y values? Okay. So what we're going to do is we're going to plug in 6 for x and we're going to solve for y. So we get 6 squared plus y squared equals 49. Well, 6 squared is that 36. So if 36 plus y squared equals 49. The goal here is to isolate for y. We've got to get y by itself. So I'm going to move 36 over to the other side. Y squared is equal to 49 minus 36. Y squared is equal to 49 minus 36 is 13, I think. I think that's right. And then this is the neat part. This is where our square roots actually become important. I got to get y by itself, so I still got to square root both sides of the equation. These square roots create an exponent of 1. And on the right side, I get the square root of 13. I've got a quick calculator here. Let me see if I can bring up a calculator real quickly. Okay, we got that piece. What is the square root of 13 approximately? 3.6 approximately, let's say. There we go. So, y equals plus or minus 3.6 approximately. Okay? So, there are actually two answers here. The answer of y equals 3.6 and y equals negative 3.6. So in other words, there's two coordinates. There's 6 and 3.6 and 6 and negative 3.6. Now remember, 3.6 is rounded just a little. I'm going to zoom out. But the reason this makes sense is because here, well, it's actually 6 and 3.6. And then if we were to draw a vertical line, look at that. It hits it at another point, 6 and negative 3.6. And then let's test it. Is it true what we just said? We're going to take these coordinates, either of them, and plug them back into this original equation. I'll do it over here. X squared plus y squared equals 49. Now remember, I rounded a little, but I should get a value really close to 49. 6 squared plus 3.6. And just to prove it, we'll use the negative one. Negative 3.6 squared, 49. 6 squared is 36 plus, let's go back to that graphing calculator. What is negative 3.6 squared? Oh, it's because it's not in brackets. There you go. It becomes positive 12.96. Okay, 12.96. And remember, we were square rooting 13, so that number's pretty close to 13. It's probably going to work out. Is equal to 49. 36 plus 12.96 is going to give me 48.96, which is approximately 49. It's not perfect. It's not the exact answer, but this is really, really close. So our estimate is probably right. It's just because we rounded that it wasn't on. And now the left side equals the right side, so that means check. Yeah, that point is on the line. Technically, it has to be exactly equal. Even this point, if they asked us originally, we would have to say it's not true. But it's because we did a little rounding just to make things a bit easier for ourselves. But that is like a crash course on the equation of a circle that has its center on the origin.